This video is going to be on making structural formulas for ionic compounds. So here's the difference between ionic and covalent compounds. Ionic compounds have a metal and a non-metal. In this case, metals are giving electrons to the non-metals. So in sodium chloride's case, sodium is giving one electron, has one valence, to chlorine. Chlorine is taking the one electron from sodium because chlorine has 7 valence, so that gives it its 8. So it's a metal giving electrons. They're not really sharing. A covalent compound, two non-metals are sharing electrons. So in this case, you have carbon with oxygen. They are sharing electrons to get to 8. Okay, we're only going to focus on ionic compounds right now. And you're going to draw what we call structural formulas. So you can do a structural formula or a chemical formula. So if I ask you to draw the structural formula or the Lewis structure. Okay, structural formula or the Lewis structure of a compound. Again, we're going to do ionic compounds only right now. So let's say we have, we'll do sodium chloride first. So you have sodium. Okay, we're going to draw the dots. So sodium has got one valence electron. Remember, just look at the top of the family to figure that out. Chlorine in the 17th family has 7 valence electrons. So sodium is going to give its valence electron to chlorine. So remember that empties out its outer energy level, so the next energy level is full. That fills chlorine outer energy level. Every time we draw a bond, that represents 2 electrons, one from each element. So a bond is 2 electrons. So we're going to draw a bond that takes up an electron from sodium, an electron from chlorine. There is a single bond between those 2 elements. Again, these 2 electrons that are in this bond are going to be used mostly by chlorine. Chlorine also has these. The number one rule to follow, no matter what we're drawing, non-metals always have 8 electrons around them. 2, 4, 6, bond counts as 2, that's 8. Non-metals always have 8. They have that octet of electrons around them. Let's say we have strontium oxide. Strontium oxide. So again, look up strontium, find how many valence electrons it has. It's got 2 valence. Oxygen has got 6 valence electrons. So strontium wants to get rid of its 2 electrons. Oxygen has 6, would like to gain 2, so it works out perfect. So whenever you have single electrons here, we can draw a bond between those. So there's a bond. These 2 would form a bond. You can either draw a bond like that, or you can erase these 2 electrons and make a bond. So remember, the bond takes up 2 electrons. Again, the non-metal has 2, 4, bond counts as 2, bond counts as 2, so it's got 8 electrons around it. Metals are giving away their electrons. That would be a double bond, okay? And those are ionic bonds. Let's say we have aluminum fluoride. Again, metal with a non-metal ionic compound. So aluminum has, look up its dots, it's got 3 valence electrons. It wants to give those 3 away, so it's probably going to form 3 bonds. Fluorine has 7 valence electrons. So fluorine cannot take all 3 electrons. It can only take 1. That's all it really wants to be stable to fill its outer energy level. So it's going to take 1 of those electrons from aluminum and form a single bond. So fluorine has got its 2, 4, 6, 8 around it. Aluminum still has 2 more electrons to get rid of. Well, you can have another fluorine. There would always be plenty of the atoms around. Aluminum can give an electron there. Okay. And then another fluorine, I'm going to take this electron, put it over here. Another fluorine here. Aluminum can give 1 there. That is not a triple bond. That would be 3 single bonds. So it's single bond, single bond, single bond. Again, every non-metal, the fluorines always have 8 electrons around them. That is your structural formula, shows the structure. The chemical formula would be AlF3. Always metal first, non-metal last. So aluminum fluoride. Aluminum fluoride. Let's say we have lithium sulfide. Notice the ending changed to "ide." So it's lithium and sulfur. The second element always changes to "ide." oxide, sulfide, fluoride, bromide. Lithium has got 1 valence electron. Sulfur's got 6 valence electrons. So sulfur needs 2 more to get to 8. Lithium has 1 to get rid of. So lithium can give 1 to sulfur. There's a bond. Again, bond takes up 2 electrons. Sulfur has 2, 4, 6, 7 electrons around it. Needs another one. Need another lithium in here to give it another electron. Lithium has got rid of their electrons. Sulfur has now got 8 around it. Your chemical formula would be Li2S, lithium sulfide, Li2S. We'll do one more ionic one. Let's say we have aluminum nitride. So aluminum has got 3 valence. Nitrogen has 5 valence. Again, remember your valence electrons, just looking at the top of the family. Nitrogen's in family 15, 5 valence electrons. Aluminum's in family 13, 3 valence electrons. So nitrogen wants to gain 3 more to get to 8. Aluminum wants to get rid of 3. So we're going to end up with a bond, a bond, a bond. I usually would draw this. Again, there's still an unshared pair of electrons on nitrogen sitting over here. So 2, 4, 6, 8 around nitrogen. Aluminum's just getting rid of them. So your formula would just be AlN, 1 aluminum atom for every 1 nitrogen atom. Again, structural formula, chemical formula.